we're expecting to drop our emissions profile by close to 84%. So it's a huge amount, very achievable, and more importantly, what it does do is it enables us to deliver lower Scope 3 outcomes for our customers.
Welcome back to Infrastructure Connections, the podcast where we explore what makes infrastructure work. I'm your host, Seth Scott, and hooray, we made it to Season 2. This season, we're going to be looking at circularity and the role it plays in infrastructure. What better way to start off than by looking at the circularity metrics of steel, something that's almost 100% recyclable? Did you know that half of all steel is used in the infrastructure and building industry, and the other half of it is used for things that use infrastructure, things like planes, trains, and automobiles? So today we'll be talking about steel with Steve Porter of InfraBuild. Steve is head of Sustainability, Innovation and Trade at InfraBuild Australia, Australia's largest integrated manufacturer and supplier of steel long products. He spent most of his career as a general manager in the steel industry, and he is committed to shaping a sustainable, low-carbon future in energy-intensive environments. Well, Steve, welcome to the show.
Yeah, thanks a lot, Seth, and thanks for inviting me. Really looking forward to this next period of time together.
So you've been working in the steel industry for 30 years now. What was it about steel that attracted you in the first place, and what's kept you in that industry all these years?
Why steel? Look, it's a good question. Certainly, it wasn't by design. I sort of just fell into it after finishing university, and over time, it's just gradually made its way into the bloodstream.
What have you seen in the industry that's changed over the years? I'm sure 30 years ago, sustainability was very different.
I think particularly around sustainability, and as a building manufacturer, products manufacturer, we have seen the emergence of sustainability for some time over that period. I would say, however, that prior to COVID, it appeared to be more what I'd sort of describe as an intangible benefit to our customers. We've seen a noticeable change post that COVID period, and now what's actually happening is our customers right across the built environment, from single dwelling housing right through tier 1 construction to major infrastructure projects, now essentially demanding lower embodied carbon construction solutions, together with improved circularity credentials as well.
It's interesting you mentioned that. I noticed the same thing across industries, was that I guess it was the threat of a global event that really woke everyone up to the idea that this was a reality and that climate change was something that they could act on. So yeah, I did notice that. It's interesting to see that in the steel industry. So how has InfraBuild been implementing circularity, and what does that look like for infrastructure?
Look, from an InfraBuild perspective, really our sustainability efforts are focused on two core activities. The first is really around the decarbonisation of our manufacturing process. The second really is focused on enhancing our material efficiency through innovation. So if I sort of just go and talk a little bit about the decarb strategy, decarbonisation strategy really is focused around the transition to 100% renewable electricity for us. Equally, the substitution of coke in our steelmaking process with sustainable biochar. And we're also looking for an alternate energy source to natural gas, which we use in our reheat furnaces. An example of that might be biomethane. So we're looking at that as one of our options. When we actually look at the concept of embracing material efficiency, however, essentially what we're really looking to do there is providing an equivalent or a superior design solution for our customers, but using less material. A really good example of that is our new Sense 600 reinforcing bar product, which we introduced to the market about 18 months ago now. So really, the combination of these two pathways really enables us to deliver low embodied carbon construction solutions for major infrastructure projects, using less material, optimising the available raw material feed that we have, and equally at the same time improving circularity, efficiency, and subsequently decreasing the environmental impacts as well.
You already have 2 electric arc furnaces online, which is putting you quite a bit ahead of the rest of the industry. Do you have plans for more, and what was the process like getting those in place?
Look, at some point, capacity constraint versus the growing market here in Australia will become a point for us. At the moment, we are actually looking at ways that we can increase our EAF capacity. That might be through a greenfield site, or otherwise looking at our existing facilities at the moment and looking at ways that we can increase capacity through those facilities. We do have options there, and we are actually investing at the moment to increase capacity through those facilities.
So your current model, rather than using virgin materials, uses recycled materials. I understand, I've seen the video, you're shredding cars and washing machines and trains. It's pretty cool. How do you manage to recycle out 90% of those recoverable materials, and how does that process work exactly?
Yeah, well, there's probably a couple of things here, and maybe I'll just sort of mention, because you were talking about our EAFs and the difference between the way that maybe we process as a secondary steelmaker, or what's called secondary versus primary. We've actually had electric arc furnaces here in Australia operating for over 40 years. So it is certainly a method of producing steel that's very attractive for the moment as the world's trying to decarbonise. So we're in a strong position, the fact we do actually have these assets and they've been operating here for an extended period of time. In terms of the scrap, we do collect a lot of scrap. We actually process through our EAFs approximately about 1.4 million tonne of scrap steel per annum. And really, in terms of that process, what we actually do is we collect scrap ourselves through our own internal business and also some external third-party scrap collectors as well. And then really, once we've collected the scrap, it runs through a pretty simple process around segregation into different grades and sizes. Some of it's shredded through a large shredding machine, and this also enables the removal of impurities like non-ferrous metals, rubber, plastics, etc., ensuring that we have the appropriate quality mix of scrap for repurposing in our electric arc furnaces. Through the EAF process, like I mentioned before, it's sort of termed a secondary steelmaking process. So what does that mean? It means that it's recycling scrap steel versus using virgin resources such as iron ore and coking coal. So to give a really simplified version of the EAF steelmaking process, essentially what it does is it melts scrap steel. So that involves us putting scrap steel, charging that into a furnace, melting the steel with electric arcs, then refining that melt with alloys to achieve the desired grade or qualities that we're actually after. And then the product's actually cast into what we call, or we term, semi-finished shapes. These are then go onto our rolling mills, and from that, in the rolling mills are actually rolled into the final shape that goes to market. Now, in terms of what we're actually producing at the moment, the primary product is actually reinforcing bar, as well as wire rod that goes into steel mesh used in construction as well. The other thing, which is probably really important to mention around the EAF technology that we're using, look, it is a very intensive energy consuming process. So really the focus here is the majority of that energy source is coming from electricity, which we get off the grid. So the one advantage of it versus traditional blast furnace steelmaking process is that it actually has an emissions profile which is around about 70% lower. So it's a significant difference. And as InfraBuild actually transitions in its decarbonisation strategy to 100% renewable electrons coming into the business, we'd expect that gap to grow even further. In fact, when you actually look at our Scope 1 and 2 emissions profile between 2020 and 2030, we're expecting to drop our emissions profile by close to 84%. So it's a huge amount, very achievable, and more importantly, what it does do is it enables us to deliver lower Scope 3 outcomes for our customers.
That's fantastic. That's a big difference. And that goal is by 2030?
Yeah, by 2030. So I mentioned sort of those three principal areas of focus in terms of the transition to renewable electricity, substitute for our coke, and we actually do have a project which we're about to embark on in terms of commercialisation of that substitute product for the sustainable biochar. And yeah, we're still working with the government and other people in market around that substitute for natural gas.
Do you use power purchase agreements for renewable electricity?
Yeah, PPAs are a big part of the success in terms of transitioning. But though it's quite complex for us, we're a very large consumer, and it does mean that we need to have multiple PPAs and marry our offtake with those new developments that are coming to the fore.
Since the steel that comes out of your factory is really basically 100% recyclable, do you have any end-of-life agreements with the end users of this for it to make its way back to you in 50 years or whenever it reaches that end of life?
Look, we don't, but look, that's certainly something that sits in front of us in terms of a market offer and working with all parties within the economy to do so. But look, at the moment, obviously, we are able to collect in excess of, or approximately 1.4 million tonne per annum. There is a lot of export. It's still scrap as well, but into the future, as I think domestic demand increases, there'll probably be less of that going offshore. But yeah, look, things like that certainly are being talked about now, and we're having interest from parties around how could that actually work.
So circularity isn't just recycling, though that's a big part of what you do, and it makes sense that because you can with your particular product. How do you promote circularity in other areas of the business?
Yeah, well, I did mention around before two of the areas around in sustainability we're focused on. So obviously decarb, the other being material efficiency. So in terms of the embracing the concept of material efficiency, really in terms of what that actually means, it means our market offer to the infrastructure projects benefits from using less steel, obviously having the lower embodied carbon. But it also enables us to lower our consumption of key material and energy inputs such as steel scrap, alloys, coke, electricity per saleable unit. So in essence, what it's doing is it's making our available resources stretch further.
Speaking of that, one of the cool things I saw that you do is you end up with slag as a byproduct of your process, and then you've used that as aggregate in the Albert Park circuit, which is the Formula One Grand Prix course. That's pretty cool. How did you end up using it that way, and what other projects are you using it for other projects in a similar way?
Each approach aims to reduce our contribution to landfill. And really, either that or providing useful raw materials for other industries. An example of that is we have a byproduct called EAF dust. Now, the EAF dust contains valuable metals such as zinc and iron units. So we actually collect this through the steelmaking process, where it's then sent to a third-party recycling facility, and then they run a process that recovers both the zinc and iron for reuse. Another example is through our rolling mills, we actually collect mill scale, and that is collected and repurposed for use as fine aggregate in cement manufacture as well. And finally, there's another, there's a range of other sort of waste areas of waste management for us, and in those at the moment we continue to invest in existing technology solutions, R&D. As well as working with government, and on the government side, that's really a focus on public policy and regulation, for example, all aimed to minimise our waste streams.
That's fantastic that you have it pretty much centered in your strategy, the reuse of existing materials, and then the management of your waste as well. How does that work out for your bottom line? I assume that means you've produced value from that waste.
Look, certainly. I think that people can term them either as waste or byproducts. I think it really depends on your frame of mind within an organisation about how you actually assess those. But the other thing also for us is a twofold. One, we have a social responsibility to manage our waste, and particularly in terms of minimising that in terms of any environmental impacts. That's the first part of it. But secondly, in most cases, there is an economic impact as well. and particularly if anything's going to landfill. Landfill is not cheap, and it's only getting more expensive. So it's also an economic incentive to find ways to repurpose any of these byproduct or waste streams and ensure that we're not putting as much into landfill.
So I understand one of the best ways to measure that is the material circularity indicator, which was developed by the Ellen MacArthur Foundation and is used by most organizations now. How does that process work? What does the MCI do for you, and what are the results?
Look, I think the good thing about the MCI indicator is that it really provides a clear metric for circularity. So, and it helps companies or support companies in terms of making strategic, informed decisions on how to reduce waste and improve resource efficiency. Now, obviously, there's some detail that goes into the calculation of that. So there are several steps in terms of calculation of the MCI value. First, obviously, there's the amount of primary and secondary materials used in the product that are measured. And then also measured is the product's lifespan and the efficiency of its recycling process. So these two factors are combined together to produce the MCI value, and that is what quantifies the product circularity. Now, essentially, that quantification is the awarding of an MCI value. Now, that is between 0.1 and 1. So the important thing here is that the higher the MCI value, the greater the product is aligned with circular economy principles. Now, if I can use the InfraBuild's new Sent 600 reinforcing bar as an example, this actually achieves a MCI value of 0.915. So in other words, it's highly circular.
And that's probably a luxury of steel, but I think that's the goal of most material manufacturers. So steel is a big part of any infrastructure project, obviously. Circularity impacts several of the credits that the IS rating is currently using, including resource efficiency and sustainable procurement, as well as leadership and management, of course. So how does InfraBuild's work on MCIs and your use of them in your EPDs help customers with their IS rating?
Well, look, I think from a customer's perspective, the MCI helps them understand the life cycle of our products. That's obviously from the raw material extraction to end-of-life opportunities, and helps them to identify how to improve the circularity of these materials. Now, that could be by keeping them in use for as long as possible, as well as including them through recycling. Now, the advantage of publishing these in our EPDs is that it also gives credibility to the value. So I mentioned the number of 0.915 for the Sent 600. The fact that it's in our EPDs are actually registered, are published by third-party certifiers, and they're based on verified data. So that becomes really important. I think the thing which is really important around MCIs then in terms of how customers use them for major infrastructure projects is the MCI value obviously provides a really good guide or a better guide for customers around the circularity of a product versus just the recycled content. Obviously, that's because it takes into that full life cycle of the product. Now, if you're looking at specifically the IS version 2.1 rating tool, this actually rewards the use of products in projects that have an MCI. So therefore, by the inclusion of MCI data and for us also the inclusion of global warming potential numbers in our EPDs, it actually enables the design and sustainability professionals who may be working on major infrastructure projects to make informed decisions regarding material choices, to maximise circularity and model the project's embodied carbon profile, for example.
So EPDs are not a small amount of work. There's a lot of data that has to be gathered, and it's almost a marketing object at this point. There's a lot of paperwork involved, of course, in that and in the rest of your circularity calculations. What makes all of that worthwhile for InfraBuild? Because we do hear a lot of companies say, well, it's too much paperwork, but obviously at the end of the day, it must be worth something to you.
Seth, right at the start of this conversation, you asked me about what changes I've seen over time in the industry with respect to sustainability. And I mentioned that shift from intangible benefit to tangible benefit. Now, this is really important to recognise because today many of our customers now value transparent, traceable data on key sustainability attributes. Obviously, to help them achieve their own decarbonisation and circularity objectives, as well as those of their clients. So, for InfraBuild as a major building product supplier to the Australian construction market, it's critical that our market offers value and it remains relevant. So, if you consider that, it's a really worthy investment.
Where do you see that circular economy happening over the next 20 years? So you said you had EAF furnaces already in place 40 years ago in some parts of the market, and now we see that adopting throughout more steel making. What other kinds of projects and processes do you see coming online over the next 20 years?
I do think that in terms of circularity, it will require a paradigm shift. And that paradigm shifts to one that prioritises prevention, product longevity, and also the inclusion of intelligent design. Maybe another way of describing that would be, a shift from I suppose what we'd probably term today the linear take, make, dispose model. And that would be moving to a more sort of restorative, regenerative type model system. Now, what would that look like? That would obviously involve around minimising waste, maximising resource utilisation through reuse, recycling and regeneration. Then I think we could expect to see a rethinking of design and production. Now, once again, what could you consider to be part of that? So, I would assume this would include, things like products being designed for longevity, ease of repair, ease of disassembly, end of life for repurposing. A much greater use of modular design, I think that's certainly going to be prevalent. A greater focus on material selection. And this is really to emphasise the use of recycled and or recyclable materials. And I think the other thing also would be elimination of waste. So that's really designing out waste from the beginning of the product life cycle. So I think that they'll be actually key, and we'll see that into the future. I think the other thing in parallel for that really is I see a shift in sort of consumer or end user behaviour as well. So we are already starting to see some of that change today in terms of behaviour around circular consumption. We see this in the rise of sharing, renting, leasing practices for many products. This coupled with improved awareness and education, and also the emergence of product stewardship. In fact, product stewardship, I think, has the potential to play a major role as the responsibility for end-of-life management to producers because it actually incentivises innovation. Now, innovation will certainly play a key role, and part of that will be obviously greater use of advanced recycling, the development, I should say, of advanced recycling technologies, digital technologies, and also biomimicry as well. I think all these things will be really instrumental in optimising resource flows, enhancing product lifecycle management, and drawing on the insights from natural systems, so as to design circular solutions and processes.
It's interesting how you've mentioned designing waste out of the system, but actually in some cases, as in your case, the waste can actually become another product and part of the system. And that's essentially designing waste out of the system by using it as a product. So that's helpful. What's one thing that you think our listeners can do to really help promote a circular economy, especially if it's not necessarily currently part of their practice?
I'd encourage listeners to spend more time thinking about the role of systems. Now, what I mean by that, for example, is taking a more holistic approach, with a focus on understanding the interconnectedness of the various elements of the circular economy. So, this would include collaborations and partnerships between businesses, governments and communities, and also taking a long-term perspective and including things like scenario planning and as well as backcasting as well. So I think if listeners can sort of embrace that type of approach, then I think we can really see a big improvement in terms of the circular economy, and the fact that the circular economy can then become a really powerful tool for achieving a more sustainable built environment.
Sounds like to that end, you must work very closely with your customers as well. What is your relationship working with customers, and how is that dialogue improving when it comes to promoting that awareness around circularity?
In recent years, the relationship and the conversations have really been improved because of really everyone trying to achieve improved sustainability outcomes. Look, I'd probably term it a safe conversation. It's a very safe space to have conversations with customers. Typically, the past is maybe a little bit more focused on the economics. But this is, as I mentioned, it's a safe space. Everyone's trying to work their way through it. And I think there is a recognition right through the value chain within the construction industry that people do need to work together to get to these outcomes. So particularly when we're looking at things like I talked before around traceability, et cetera, a lot of that comes into digitizing, the digitalization of information, the security of that information, et cetera. So once again, there's a lot of work that we're doing with customers all the way through the value chain in that area as well. Now that also brings productivity benefits and a whole cast of other things as well. So I think people are starting to realise that by working together around sustainability, it can deliver a lot of other economic value to the organisation as well.
It's very positive. It's good to hear that kind of a positive vibe that's happening out in the industry. And it's good to see an industry like yours that's really adopted circularity, really made it a major part of the way you operate and had such fantastic results come out of it. That's great to hear. Well, I really appreciate listening to this. This has been great. Thanks so much, Steve.
Once again, really appreciate the time, the opportunity to spend the time with you.
Thank you for listening to Infrastructure Connections. Please take a moment to follow us or subscribe wherever you get your podcasts and tell a friend. And hey, we want to know what you think. Drop us a comment down below to let us know what you think about sustainability, circularity, or steel. Until then, stay tuned for the next episode of Infrastructure Connections.